everyone, welcome back. Okay, so let us start off the new year with a good round of integral and differential calculus. Okay, Pramod, Lovepreet, Aishwarya, Manish, Bharat, Ritu, Sindhu, and Alpithangar. A very good afternoon and a very happy new year to all of you also. Kavya, Ayushi, Aryan, and Nikita also. Yes, thank you so much for your wishes. They mean a lot. And I hope you also have a successful new year this year. Okay, 2023. So, okay, let us go to differential and integral calculus. So, for today, we are going to talk about differential calculus. Now, see, what happens here is that you may have heard from somebody, it's difficult, this, that, but it's not so. What you have to do in differential calculus is that you have to pay a little bit of attention. Okay, you must know the certain formula. Yes, no doubt about it. But those formulas are not very big ones. Okay, those are okay ones. But what you have to remember is that it is more of application, which formula to apply. So how do I come to know that? By doing more and more sums. Okay, so the practice will make you perfect. So let us go into it. Let me just take the. Yes. Okay. So what is differential? To express the rate of change in any function, we introduce the concept of derivatives, which involves a very small change in the dependent variable with reference to a very small change in the independent variable. So what happens is that when this is used, when we are studying the effect of one variable over another. Okay, you may have one or more variables, but we have only this in our syllabus. So we are talking of only two variables. One is the dependent variable and one is the independent variable. Okay, so as and when the independent variable changes, what is the effect on the dependent variable, or with at what rate will it change, that we are going to see over here. Differential integral have a very big practical application. Okay, so this is a very important concept and very interesting also. Okay, so what they're saying is differentiation is the process of finding the derivative of a continuous function. It is defined as the limiting value of the ratio of change in the function corresponding to a small change in the independent variable as the latter tends to 0. Okay. Now here important word is argument in the independent variable or the argument. So independent variable is also called as argument. Okay. And increment, here we are talking of a very small minute change. So what is differentiation? It is a finding of the derivative of a continuous function. Okay, so the function has to be continuous. It is defined as the limiting value of the ratio of change in the function corresponding to a small change in the independent variable. So this is just for the concept. What does, they may just ask you, how do I write derivative in terms of the first principle? Okay, they may give you 4 options and you may be asked to tick the correct answer. So that is why we are doing this. Actually, while solving problems, we will not be using this, because we don't have to show it by calculation. We just have to tick mark the correct answer. Yes, Surya, Kevin, Sunil, Dimple, Sadhna, Aishwarya, Akshata, Liza, Purvas, then Ashutosh, Sunil, Ankur, Tamanna, Swati, Ananya, Satyajit, and Aran Kumar. Okay. Yes, Aran Kumar, that is what I am telling you, what derivative means. Okay. Yes, Sirigauri. Hi, hello. Okay. So what this is that we have to write limit as h tends to 0. What is h? H is a very small increment in the independent variable we are taking. So obviously my x changes to x plus h, then minus fx, that is the original function, upon h. Okay. So then this derivative is defined as limit. LIM is limit h tending to 0 f of x plus h minus fx upon h. This is also written in this form, limit delta x tending to 0, okay, is f of x plus delta x minus fx upon delta x. Okay. So function f is y is fx. Okay, I am saying function y is fx. H, see, h or delta x be the small increment. So I can write it in this form or I can write it in this form. I'm showing you purposely both the options because you may get any of this. So you must know that h is nothing but delta x. Okay, and delta y is f of x plus h minus fx. Okay. This is written as f dash x. Or you can also write this as d by dx of fx. It is d by dx of fx. Okay, this is derivative. D by dx is derivative. Okay, even if in the books you find it as written as this, it does not mean df divided by dx. Okay, it does not mean normal division. Okay, this, it is supposed to be this d by dx of fx, but for writing and printing ease we write it as df by dx. This is actually derivative of f with respect to x. This is what derivative of fx with respect to x. This is given as df by dx. This process of differentiation is called as the first principle or definition or ab initio. Okay, it's also called as ab initio. Okay, so either of this you can use it. Okay, the words may be used differently, but this is mainly this meaning of first principle or ab initio is f dash x is given by limit of h tending to 0 f of x plus h minus fx upon h. Okay, I've written it again, so this is how it looks like. Limit h tending to 0 is f of x plus h minus fx upon h. This is written as f dash x, or it is written as d by dx of f of x, which is equal to f dash x, which is equal to d by dx of fx. Okay, so now we'll be talking about the formula. These are the important formulas. For derivatives. So d by dx of xn is given by n x raised to n minus 1. This page you have to learn by heart. Okay, this you have to know. D by dx of x raised to n is n into x raised to n minus 1. So that if I have to find the derivative of x raised to 6, then d by dx of x raised to 6. What is n here? N is this 6. N is equal to 6. What will be n minus 1? 6 minus 1, 5. So this will be equal to n, that is 6, x raised to n minus 1, that is n 6 minus 1, so x raised to 5. So derivative of x raised to 6 is equal to 6x raised to 5. Okay. Now derivative of e raised to x is e raised to x. So this is simple. Whenever you're trying to find the derivative of an exponential function, it will be the exponential function, provided this is only raised to x. Okay, if there is something else over here, e raised to x square or e raised to 2x, then the answer will be different. This is only for e raised to x. This is only for e raised to x. Third is d by dx of a raised to x. Now what is the difference between x raised to n and a raised to x? A raised to x is in that a itself is a number. So the a raised to x, you can have 3 raised to x. Okay, I can have 3 raised to x or 5 raised to x. So when I have to find derivative of this, always remember this is not equal to x raised to 3. Okay, this you have to remember. Okay, sometimes students get confused. So let me just tell you that this is not equal to x raised to 3. So x raised to 3 is not equal to 3 raised to x. This is the formula. Suppose I have x raised to 3, I will use this formula. If I have 3 raised to x, I will use this formula. Okay. This is why I have taken this sheet so that you can see that what the formula, because sometimes you may not mistakenly use the incorrect formula. Okay. Then d by dx of a constant is 0. See, what is the concept of derivative? Derivative is saying that when I have a small change in the independent variable, how much will my dependent variable change? Now, my dependent in this case is a constant. Suppose I have the equation x is equal to 5. Is the value of x going to change? Is the value of x going to change? No. X is always going to be 5 irrespective of what the value of y is or what changes take place. So what happens is, y is equal to x. Y is equal to 5. Suppose I have this. Y is equal to 5. So whatever changes in the independent variable x takes place, so y will always be equal to 5. How does it look on the graph? This is my x, it is going on. And this is my 5. So my line is going like this. Is my line going to change for any? Now here x is 0, then I have 1, 2, 3. Is my value of y going to change? No, it is a constant. So what is the derivative? What is the change in y? When x changes, there is no change. When there is no change, I write it as equal to 0. Okay, so if you've understood even the formula with respect to the concept behind it, you will get this. Okay, then d by dx of e raised to ax. Okay, as I was saying that this takes place only when this is a formula is equal to e raised to x, only when the power of e is only x. Now here you can see the power of e is ax. Then this is given by, this is similar to this. Okay, d by dx of a raised to x is a e raised to ax. Okay, so suppose I have derivative d by dx of e raised to 4x, then this is equal to 4 e raised to 4x. Okay, this means this. Here what is a? A is 4 in this case. So this is 4 e raised to 4x. Okay, d by dx of log x. So logarithm if I take is equal to 1 upon x. Okay. Also, suppose I have a function. So suppose I have 5x and I want to find the derivative of 5x. Okay, d by dx of 5x. So what are they saying? C into fx. So this, what is c here? C is 5. What is x here? This is equal to fx. So this is equal to 5 d by dx of x, which is equal to how much? 5 into 1, which is equal to 5. Okay. So these are the formulas that you should know. Yes, Satyajit, thank you. Happy New Year to you also. Aditi, Ashutosh, Prakati. Yes, Mahima, I'll just repeat it. Yes, Ritu, I'm fine. Yes, Manish, if you have it in the 12th standard, if you've already done it, good. Ankur, that's just a name, you know, you don't have to go into too much of detail over here. Aisha, can you see the screen now? I think because we are showing it properly, just refresh your screen, maybe you'll be able to see it. Okay. Okay. So let us just recap this, that when we are talking of derivative, we say that to express rate of change of the function, we introduce the concept of derivative. It is a differentiation is a process of finding the derivative of a continuous function. Okay, then we are talking about the first principle. First principle, you also called it as ab initio. So what does it say? F dash x is equal to limit h going to 0. What is h? H is a small increment in the independent variable x in this case, and f dash x is given by limit h going to 0 f of x plus h minus fx upon h. Okay, and then we are talking of these important formulas. So for let us see quickly. So if my fx is equal to x square, then my d by dx of, so I write it as f dash x is equal to, what is this? This formula I am going to use. D by dx of x raised to n is n x raised to n minus 1. What is n? N is 2 over here. Okay. So 2x raised to 2 minus 1, which is equal to 1, which is equal. So this is 2x. Now fx of e raised to x. What is d by dx of e raised to x? It is equal to e raised to x. So f dash x is equal to e raised to x. If my function is equal to c is a constant in this case, then my f dash x d by dx of a constant is how much? It is equal to 0. So this is equal to 0. Then f of x is x raised to n. So derivative of x raised to n is n x raised to n minus 1. So f dash x is equal to n x raised to n minus 1. Fx is equal to a raised to x. So d by dx of a raised to x is a raised to x log a to the base e. So this is equal to f dash x is equal to a raised to x log a to the base e. Okay. So this is the natural log. Now derivative of root of x. So I will write first this as fx is equal to x raised to half indices. Okay, now x raised to half. So I'm using d by dx of x raised to n is n x raised to n minus 1. So f dash x is equal to n, that is 1 half, x raised to 1 half minus 1. From 1 half, if I'm trying to subtract 1, what do I get? I get minus 1 half. So this is equal to 1 by 2 x raised to minus 1 half. Okay. Remember in indices we have written a raised to minus 1 is equal to 1 upon a. So this is x raised to minus half. This is equal to 1 half x raised to 1 half. Okay, so what do I write? This is equal to 1 upon 2x raised to 1 half. Okay, minus 1 half becomes plus 1 half when we go into denominator. This is written as 1 upon 2 square root of x. Okay, so x raised to half can be written as square root of x. Fx of log x, then f dash x will be equal to, what is d by dx of log x? It is equal to 1 upon x. So this is equal to 1 upon x. Okay, so quickly we have seen what are the different formulae and how to use the formulae in a proper manner. Okay, has everybody understood till now? Ritu, there are not much of calculated tricks here, because actually calculation wise there won't be anything. This is more of whether you know which formula to use and whether you are able to apply it. Okay, Nabin, yes. Which second formula, Kavya? e raised to x. Okay, e raised to x is an exponential curve. Okay, exponential. So that is a very important concept in mathematics. So, but you will not need it much. So you just remember e raised to x is called as the exponential. Okay. Thomas continuous function is a function which is continuous over the given range. Okay, so that you will be able to draw a smooth curve when you try to plot all the points. So 5-6 formula. Yes, very good, very good. Yes, Alpithanga, you use derivatives when you want to minimize the cost or maximize the profit. You want to find the area under the curve. Okay, when you go as business analyst, that time also you will be needing. And so as a CA, you always want to reduce the cost, increase the profit in even in case of manufacturing. So that. Aditi, the weightage etc. is given on the on the website, so you can see from there. Yes, Maima, all the formula I have explained with the example only. No? These are the examples that we have taken. So all these are examples, right? So, and all the whole chapter is about examples only we are going to solve using this formula. Okay. Formula number 3. What formula is 3? Okay, a raised to x. So what I was telling you earlier was, see, when I have a number raised to x, okay, I have 3 raised to x. Suppose, see, I have this 3 raised to 5, okay. So, or I may have 3 raised to 4. So this number may keep on changing. So what do I write? I write it as 3 raised to x. So I may write it as that my function fx is equal to 3 raised to x going from 1 to 3. Okay, 1 to 5 suppose. So what will happen? This will be equal to 3 raised to 1, 3 raised to 2. Remember in geometric progression we have done. So this is what 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4 and 3 raised to 5. Okay. So this is what is meant by f of x. Okay. Now suppose my x is equal to 3 or 4 suppose. Then my fx will be equal to how much? This will be equal to 3 raised to x, which is equal to f of 4 will be equal to 3 raised to 4. Okay, this is the meaning of it. And when I want to find the derivative, this derivative is a raised to x log a to the base e, which are the natural logs. Okay, so these concepts you just have to need to know the names. Okay, you don't have to go into deep or how to find the exponential, how to find the natural log. Okay, log of a to the base e, then that is enough for you. Okay. Aditi Institute's ICA website. Yes, Manish will be taking the question. Yes, Shruti. Good, you have understood? Yes, Asif, you have to read all the formula. You must know the formula. Yes. See, Anushka is also telling you, these are all, this is an easy chapter. She said she has already done it in her 12th standard, so it's easy. So that means the chapter is easy. Only thing is you have to pay attention, right? Okay. So we have used the formula. Now see, what I'm going to do is I'm going to show you the sum. I'm going to show you which formula to use. Okay, so there is no confusion. Fx is, see, when I'm writing fx, I write the derivative as f dash x. Okay. My function is x raised to n. What will be its derivative? N x raised to n minus 1. If my function is e raised to ax, then it is a e raised to ax. So example of this is e raised to 5x. So here this is my a and this is my x. Okay, so a e raised to ax will be the derivative. So what will be the derivative for this? It will be 5 e raised to 5x. Then what is the derivative of log x? It is equal to 1 upon x. What is the derivative of a raised to x? It is a raised to x log e. So suppose I have 3 raised to 4, like in the earlier 3 raised to x. Then this will be equal to 3 raised to x log of 3 to the base e. Okay. Mostly they will give you the value of log 3 to the base e in there, or you may get the log tables, and from there you can easily find the log of 3 and then write it. Okay. What is derivative of a constant? It is always equal to 0, right? Now there are basic laws of differentiation. Like we have laws of mathematics, similarly you have laws of differentiation. Now, f of x is equal to c f of x, where c is a real constant. What is it called? Scalar multiple of a function. You don't have to do anything over here. What this simply means is that if I have a function 5x and if I have to find the derivative, this means that I will write 5 dx by dx. Okay. So I can take that function, that constant out of the derivative. So d by dx of hx is equal to c d by dx of fx. This is a scalar multiple of a function, sum difference of a function, product of a function, quotient of a function, and if the function contains another function embedded in it, how to find the derivative. Okay. We are taking one by one. Okay. So these are the 5 functions that we will be discussing. And in those 5 functions, what we have is the first function. First function says that if I have a constant and a function, and those are multiplied with each other, and I want to find its derivative, then we say that this is equal to c f of x is my function. So how do I do it? Suppose my y is equal to 5x square. Then I want to find dy by dx. Then this is d by dx of 5x square. What this principle is telling you, or what this law is telling you, that I can take this 5 outside the derivative. So here I have, then c is taking out of the derivative. So this will become 5 d by dx of x square. Now derivative, what formula will I use? D by dx of x raised to n is equal to n x raised to n minus 1. So this is equal to 5. What is n here? N is 2. So 5 into 2 into x raised to 2 minus 1. So x raised to 2 minus 1, which is equal to 5 into 2. X raised to 2 minus 1 is 1, which is equal to 10x. Okay. I repeat, let me take another example. Y is equal to minus 3x cubed. Okay. Then dy by dx will be equal to d by dx of minus 3x cubed. I take minus 3 outside the derivative. This is equal to minus 3 d by dx of x cubed. What is the derivative of x cubed? I use this formula. D by dx of x cubed will be 3 x raised to 3 minus 1. What is 3 minus 1? 2. So this is equal to what? This is equal to minus 3 into 3 x raised to 3 minus 1, which is equal to 9x square. Okay, this is the meaning of this formula. Okay, this is the example I'm taking for increasing your understanding. And what is it called? Scalar multiplication of a function. Then sum and difference of the function. What is it? That if I have two functions and the sign between them is addition or subtraction, what happens in this case is when I want to find the derivative, you find the individual derivative and add them up. So suppose I have my function y is equal to x square plus 4, then y dash, which is also called as d by dx of x square plus 4. This can be written as d by dx of x square plus d by dx of 4. Okay, because this is as good as fx plus gx. What is fx? fx is x square. What is gx? gx is 4. So d by dx of x square, I'm going to use the formula y dash is equal to n x raised to n minus 1, because this is x raised to n. So this will be equal to 2x. Okay, x square derivative will be 2x. What is the derivative of a constant? Derivative of a constant is always equal to 0. So 2x plus 0, which is equal to 2x. Okay. So if I have two functions and there is an addition or a subtraction sign, then its derivative is equal to finding the derivatives individually and adding or subtracting them. Is that clear till here? Yes, very good, Dimple. You've understood. Ankur, Ritu. Excellent. I hope the others have understood also. Just put it in the chat box so that I know. See, once you've understood the formula, there is no problem. Yes, Ankur, you can solve it directly without any steps. The steps I'm giving you for those who are doing it for the first time. Okay. Yes, Vadekar. Yes. Yes, there is a minus sign here. Yes, Ritu. Aisha, where did the minus 9 come from? So this is minus 3 into 3. Therefore, it is minus 9. Okay. Yes, Mahima got it. Very good. Yes, 9 is negative. Yes, Manish. Shruti, what do you want? Purva? Yes, Kevin. That's what life is, right? The more now you are pursuing a professional degree, right? So things will be a little more complicated. And that's why the CS command a big respect, isn't it? Because they studied so hard, they've learned so many new things. Okay, that's why you should be very proud and you should work very hard for it. Okay, yeah. Don't worry, we are going to do sums also. Okay, so we are just doing that itself. So we have taken plus and minus. Okay, addition, subtractions, the formula we have taken. What does it mean that if I have two functions, okay, if my functions are fx plus gx and I want to find that y is equal to suppose this, then y dash will be equal to y. Find the individual derivative of both the functions and add them up. What will happen if there is a minus sign? Fx minus gx, then your derivative will be minus. Okay, so in both the cases, you are getting this. Okay. Now you have a little bit complicated formula. Okay. So please pay attention to this formula and the next one. If my h is a product of two functions, if my h is a product of two functions, fx into gx, okay, then what will happen is, for example, if I have something like e raised to x, x square, or x square log x, okay, these are the type of this. These are just an example of this type of function where the function is a product of two or more functions. Okay, it's not only two, you can have more also. Okay, then if I want to find the derivative of such function, what will happen is, here I'm saying that hx is equal to fx into gx. Then when I want to find the derivative, h dash x is equal to first function into derivative of second. So this derivative of the composite function hx is given by first function into derivative of second function plus second function into derivative of first. Okay, this is the word. Okay, so you can write it down in words. Sometimes, just looking at this formula, you feel it is so complicated. Actually, it is not. Because they use the d by dx, it may look big. It is simply that h dash x is equal to fx into g dash x, first function into derivative of second, plus second function gx into derivative of first. Is that clear? Yes. I want all of you to pay attention to the formula. Yes, Shruti. Yes, Shruti, we will be doing the sum, so you understood. Good, you understood, but Asif, Tanmeet, yes. Yes, Shruti, very good. Shruti said she worked very hard. How minus 1 came upside? Where? Where, Asif? Okay. Now the fourth one, this one and the next one. So what does it say? That if my function is a product of two functions, then the formula for finding the derivative of this function is first function into derivative of second plus second function into derivative of first. Okay. You may then have what is a division of two functions. My function is a division of two functions. Like, for example, my fx can be e raised to x upon x raised to 3. Okay, I may have a function fx which is equal to e raised to x into upon x raised to 3. Then this is what? This is my fx, this hx, sorry. Let me take it as h. Then this is my first function and this is my second function. I call it as gx and I give it the value 2. Okay, it's a second function. Okay, fx will be the first function and gx will be the second function. Then when I want to find the derivative, then h dash x, finding the derivative will be equal to, write it down, in the denominator, second function whole square. It is written as second function whole square. Okay. So h dash x will be equal to in the denominator second function whole square. Now gx into d by dx of fx means what? Second function into derivative of first minus first into derivative of second. Okay. So this is how you will get the answer. Okay. When I have a function which is a composite function of division of two functions, then the derivative of this composite function is given by, in the denominator write down second function whole square, in the numerator write down second function into derivative of first plus minus derivative of second into first function. So this is written as gx into f dash x minus fx into g dash x upon gx the whole square. Is that clear? Okay. Yes, Vipul got it. Excellent. Ritu, everything is very clear. Aishwarya, I hope you've understood. Yes, Dimple. Yes. Yes, Kevin, it is the UV and the NV, but we use those terminology in the in the integral. So we are using here simple, because I don't want you to get confused between whether it's a formula for derivative or for integration. Okay. Okay. Good. So many people have understood. That's so nice. Okay. Now let us go further. There is one more. Now what happens is my function has a function embedded in it. Then when I want to find a derivative, what I should do is, for the embedded function, I will use substitution. For the embedded function, so here I substitute, say we are talking into two variables x and y. Let substitute x z is equal to, here, like here it is g of x. Okay, so here what we do is, then when I want to find h dash x, which will be equal to d by dx of f of g of x plus g of x into f dash x. Okay. Wait. This is not. I thought I'm re-explaining. I'm explaining this one again. So then d by dx of f of gx is given by. Now here what is happening? Pay attention here. Okay, what is happening to gx? Now I have z is equal to gx. Okay, I have z to be equal to gx. Let me differentiate both the sides with respect to x. So differentiating on both sides with respect to x. is dz upon dx is equal to dz upon d by dz of g dash gx. Okay. So this I have to find out. Okay. Now here what happens is I will be writing this as, now how do I write? How do I write f of g of x? F of g of x. Instead of g of x, what am I going to write? I'm going to write z. So this is equal to f of z. It is similar to our function fx. Okay. But here what is the variable? The variable is z. Now when I want to find the derivative, what will happen is f dash of z. Okay. F dash of z will be inside the bracket. So what I do is this is equal to d by dz, because now this function f of g of x has now become what? It has become f of z. So instead of finding the derivative of this, what I do is I have to first find the derivative with respect to z. So this is d by dz of f dash of z. Okay, d by dz of f dash of z. D by dA of this. So once I know this, okay, I have written all the ways in which you can get this be written. So I have the formula d by dz, d by dx of hx d by dx of hx is equal to d by dz of hx hz plus into dz by dx. Okay, into dz by dx. Okay, so let me explain this again. What important thing is this substitution? Okay, this substitution is very important, because I have written everything for the explanation purpose, but while solving you will not need everything. You will just need this one step and this two step and this third step. Okay, so okay, so what is happening here? I have a function hx which is a f of g of x. Okay, this is the type of function I have. So in the function f there is a function gx which is embedded in it. So what I do is, first step, substitute z to be equal to gx. Okay, in this formula, then my hx, what does hx become? It changes to f of z. Okay, my fx, hx will change from x to z. Then when I have to find the derivative, what will happen? D by dx of h of x is equal to d by dz of f of z. Okay, why? Because we have substituted z to be equal to gx into dz upon dx. So you will get the answer. Is that clear? Once we do the sum, that time it will be easy for you. Yes, Swati understood. Aishwarya, Shruti, Ankur. Fifth once more. Yes, Vipul, Tamanna. Say, let us see. Let it be that my hx is equal to e raised to 2x square plus 5. Okay. Now, what normally I have done, that I have the formula d by dx of e raised to x is equal to e raised to x. Very simple. But here it is not e raised to 8, it is e raised to 2x square plus 5. So in this case, what will happen is hx, in this case, let 2x square plus 5 to be equal to y, to equal to z. Here we are using the terminology z. Then finding the derivative on both sides, what will the derivative of 2x square? It will be 4x plus 0 is equal to dz by dx. Okay, so this is the meaning what we are trying to do. Now I have the value of dz to dx, but I want to find this derivative of this function. Then derivative of that function is given by d by d of x will be equal to f e raised to. So this will now become hx, which is equal to e raised to 2x square plus 5 will be equal to e raised to z. 2x square plus 5 will become z. Okay, now what will happen here is this is equal to, what is the derivative of e raised to x? It is e raised to x. I find d by dx of h to be equal to d by dz of h into dz upon dA. Okay. So what is, this is d. So what will be the value? Okay, you can substitute and see. Okay, what is f of df upon dz? What is the value we have calculated? With respect to z, it will be 4x. It will be equal to 4x into dz by dA. dz by dA we have just calculated. dz by dA we have just calculated and we have got the answer. Okay. So let us do more sums and it will become more and more clear. Those are very simple things. All you need to do is you have to understand that first I have to substitute for the function, because there is one function and inside that there is another function. That another function I will substitute. Okay, once I have substituted that, what will I do? I will take that and I will find the derivative in those terms. Okay. So what are we doing there? That I am finding df to dz and into dz to dx. Okay. Instead of finding df by dz, dx by dx, df by dx, I am finding df by dz into dz upon dx. Okay. Once I do that, I find the value of df to dx. Now I have to find 3x square plus 5x minus 2. Kevin, but you have to know the formula, because what happens is once you get, maybe in a theory question you get you have to tick mark the correct formula, then what will happen? So as a teacher, I'm supposed to be telling you this is the formula and then we will be doing the examples also. Okay. So df by dx, this is not looking clear. Okay. df by dx can be written as df to dz into dz to dx. Okay. So derivative with respect to x, I can see what it means is, suppose I'm here at point A and I'm at point B. So I can either go like this or I can go like this. So what happens is that I may go from A to C and then C to B. So this is also possible. So this is what is that if I'm to find the derivative with respect to one variable, I can first find the it with respect to another variable and then find the derivative of the another variable with the original independent variable. Okay. So let us concentrate on this. This is d by dx of 3x square plus 5x plus minus 2. What did we know about d by dx upon of fx plus gx? This is equal to f of d by dx of f of x plus d by dx of g of x. So what will this be? This is equal to that I have to find the derivative of each individual formula, each individual function. This is equal to d by dx of 3x square plus d by dx of 5x minus d by dx of d by dx of 3. Okay. So what will this become? This Welcome back. Okay. So we are doing this sum d by dx of 3x square plus 5x minus 2. This can be written as d by dx of 3x square plus d by dx of 5x minus d by dx of 2. Okay. This is d by dx of. So what is this? This will be equal to, which formula I am going to use for 3x square? I am going to use this. But I am also going to use what? I am going to use the property that d by dx of c into fx is equal to c into d by dx of fx. Okay. Simply means that if I have a function which is multiplied by a constant, I will take the constant outside. Okay. So this means this is equal to 3 d by dx of x square. Okay. Plus 5 d by dx of x, and this will be d by dx of what? This is derivative of a constant. Okay. So minus d by dx of 2. Okay. This is a step. Once you are able to overcome this step, then it becomes easy. Now 3 d by dx of x square. What is the derivative of x square? X raised to 2. X raised to 2 is 2. X raised to 2 minus 1. What is 2 minus 1? 1. So this is equal to 3 into bracket 2x. Derivative of x square is 2x. Where did I get this 2x from? This is n into x raised to n minus 1. Derivative of x square, which formula I am going to use? Derivative of x raised to n, which is n x raised to n minus 1. So this is x square will be 2 into x raised to n minus 1. So 2x plus 5. Derivative of x is always equal to 1. Remember, derivative of x is 1. So this is 5 into 1. What is derivative of a constant? Derivative of a constant is 0. Keep saying this, so it becomes very easy. So 3 into 2x is 6x plus 5 into 1 is 5. Okay, this is the answer. Yes, everybody? Yes. Asif, where is it? 3? Yes, it is 2 only. Yes. Yes, welcome back. Yes, Ankur, 6x plus 5. Okay. Yes, Pramod, you understood now very clearly. Excellent. Okay. So let us do so many sums that all your doubts will be cleared. Okay. Now this. This is the sum because I know many of you get confused between x raised to a and a raised to x. So let us clear this. Now here what is happening is a raised to x plus x raised to a plus a raised to x. This is one formula I'll be using, that is d by dx of a raised to x is a raised to x log e. And what about the formula for this one? Okay. This and this have different, this and this have different formula. Okay. Remember, this a raised to x and a raised to a have similar. But what happens over here, you will have different. Okay. So I will also be using d by dx of x raised to n to be equal to n x raised to n minus n x raised to n minus 1. Okay. So what do I have? This is equal to d by dx of a raised to x plus d by dx of x raised to a plus d by dx of a raised to a. Okay. Which is equal to how much? Just put in the chat box. I want each one of you to solve it. Yes, Tanmeet, Nikita, Kavya. Yes, Nabeen. Yes, Nabeen, it is now seems easy. Very good. Shruti, yes, you've understood. I want this answer. Tell me what the answer is. What will be d by dx of a raised to x? D by dx of a raised to x will be a raised to x log a. Yes? Excellent. So many of you got correct answer. Very nice. This is equal to a raised to x log a to the base e. What is d by dx of x raised to a? This is this. So plus a x raised to a minus 1. What about d by dx of a raised to a? What is a? A is a constant. So a raised to a will also be a constant. Okay. A is a constant. A raised to a will also be a constant. So d by dx of a raised to a will be 0. Derivative of a constant is 0. So I have a x raised to a minus 1 will be the answer. Okay. Now let us take this next sum. The bigger the formula, the sum looks, the easier it is. Always remember in derivative and integration, smaller questions are dangerous, but bigger sums are good. Yes, Anushka, Kevin. See, A is always given to you as constant. This is what we assume. Okay, when we are talking of A, we are talking of C. It is constant. Okay, until unless it is written a square plus b square, that is different. Here in derivative integration, for constant we write CA. Okay, in the formula also, d by dx of a raised to x. I have showed you over here, right? When we discussed the formula, did you join a little late? Okay, here also I was telling you a raised to x is what? 3 raised to 5. 3 raised to x, for example. So what is 3? 3 is a constant, right? Or you may have 5 raised to x. So this 5 will be a constant, correct? Okay. So we have done this, and we are now going to do this. Now, see, once you've understood the concept, you don't have to write every time. Now we are going to form the sum, we are going to directly use the formula. Okay, you don't have to write everything. Only you have to be careful whether you are using the derivative formula for multiplication, whether it is addition of functions or multiplication of functions or division of functions. Okay, now in this question, can you see 1/3 of x cube minus 5x square plus 6x minus 2 log x plus 3. Okay, there is no multiplication of two functions. It is simply addition and subtraction of function. Okay, this is an example of addition and subtraction of functions. Okay, so in this we will directly solve this. This is equal to 1/3. What is the derivative of x cube? Using this, x raised to n is n, x raised to n minus 1, x cube will be 3, into x square. Okay, 3 minus 1, which is equal to 2. Minus 5. What is the derivative of x square? X square will be 2x raised to 2 minus 1. 2 minus 1 is 1. So 2 into x plus 6. Derivative of x, you know, is always equal to 1. Minus 2 log x. What is the derivative of log x? 1 upon x. Plus derivative of 3 is 0. Why? Because derivative of a constant is always 0. Okay. So this 3 will cancel with this 3. This is equal to x square minus 10x. 5 into 2 is 10x. 6 into 1 is 6 minus 2 upon x. Okay. Will be the derivative of the given function. Let me write it neatly. X square minus 10x plus 6 minus 2 upon x. Understood? Can you see now? It becomes simpler and simpler. X square 10x 6 minus 2. Yes, Ankur, very good. Yeah, I understood what you have. Yes, Baba Sahib. Excellent, excellent. Tanmeet also got. Ankur, Anushka, Kevin. Yes, Nabeen, that is the important thing. The bigger the question, simpler is the answer. Okay. Okay, Aditi, I hope you have understood now. You're no longer afraid. Now you have to be careful. Okay. Now we are going into the multiplication and division sums also. So what happens? What is my first function? This is my first function, fx. This is my second function, gx. Fx is the first function, gx is the second function. Okay. So you have h of x is multiplication of two functions. So you have to first check, is there an addition and subtraction here? There is no addition and subtraction. Is it one function? Like something like, if you have something like 2x, this is one function. Okay, because 2 is a constant, so you don't have to bother or worry. But here what is happening, this e raised to x also has x, log x also has x, so we are using the product of function formula. We are therefore using the product of function formula. Okay. So we have, what is the e raised to x function, log x function. So here what is the formula? F dash. So I will write it in terms of f dash. H dash x is equal to first function, that is fx, into derivative of second function, that is g dash x, plus second function into derivative of first function. Okay. Now, there are two ways of doing it. Either you can do it directly over here, or if you're not very comfortable initially, you can find the derivative separately here. Okay, what I have done, I will write down. Fx is how much? Fx is e raised to x. What is gx? Gx is log x. Okay. Now, what will be f dash x? What is the derivative of an exponential e raised to x? D by dx of e raised to x is e raised to x. What is the derivative of log x? D by dx of log x is 1 upon x. Okay. So, we'll be using this. We'll be using this. We'll be using this and this. These four things. Once I write it over here, I just have to use this and substitute. Isn't it very interesting? So what will I write? First function, okay, this is, let me use another ink. 1, 2, 3, and 4. Okay. First function, that is, I will write 1, that is e raised to x, into derivative of second, that is second, into 1 upon x, plus gx is third, so log x, into derivative, that is e raised to x. So this is e raised to x upon x plus log x. Okay. Now you may have answer like this, or you may have e raised to x, they take out common, 1 upon x plus log x. Okay. You may have like this, or you may even have e raised to x upon x. This is x log x plus 1. Okay. These are all simply, I've taken the LCM, taken it out of the bracket, inside the bracket. Very, very simple. So you may have answer in this form, you may have answer in this form, or you may have answer in this form. Okay. In either of the condition, see, you most of the time you have come to the answer, but because the way you have presented the answer and the options that are available, they're so different, you feel. But if you just take if you don't panic and just take a neat look, you will be able to see that they are one and the same thing. Okay. So your answer in the exam will be in either of these three, and it's an MCQ, so you will be able to find out. Yeah. Yes, Swati, very good. Excellent, excellent. Yes. Yes, Anushka. See, I have also written the third option. Yes, Shruti. Okay, is that clear? Perfectly clear? You are now confident? Just put it in the chat box. Now you're confident. You will not skip questions on derivatives. Okay, derivative integration you will take, because each mark is so important for passing also, and because now you're not afraid of this topic, you will be able to do it very well. Okay. For those who have not understood, I will just show it here. Once again, it is e raised to x log x. I put e raised to x is equal to fx. Put log x to be equal to gx. Okay. Then f dash x is equal to e raised to x, because derivative of e raised to x is e raised to x, and g dash x is equal to 1 upon x. Now I just have to write it. This is the first, this is second, this is third, and this is fourth. Okay. So d by dx of e raised to x log x is equal to first function into derivative of second function. Okay. 1 into 2 plus third function into derivative of first function. Okay. This can be written as e raised to x upon x into bracket 1 plus log x into e raised to x. This can be written as e raised to x upon x 1 plus e raised to x log x. Okay, now I took this outside the bracket. This is e raised to x upon x plus log x into e raised to x. Now I can take e raised to x common. So e raised to x I take common, what will remain? 1 upon x plus log x. Now this I can simplify, because what is the denominator here? 1. So this is written as e raised to x. What is the LCM of x and 1? It is x. 1 plus x log x. 1 plus x log x. This is written as e raised to x upon x into bracket 1 plus x log x. Okay. Okay. Or you may even have this as e raised to x upon x. I can have x log x plus 1. It will mean one and the same thing. Okay. Is that clear now? Quickly put in the chat box. And if you have understood this, you should be able to do this next sum on your own. Okay. 2 raised to x into x raised to 5. Yes, Ritu, clearly understood? Yes, Dimple, got the answer? Excellent. Now you're confident, Vipul? Tanmeet, yes, raring to do more sums. So, can you quickly put the answer here? What will be my fx? Fx will be 2 raised to x. Fx is equal to 2 raised to x. What will be f dash x? What was the derivative of 2 raised to x? We have derivative of a raised to x is a raised to x log e. So this is equal to 2 raised to x log 2 to the base e. Okay. What is my gx? Gx is equal to x raised to 5. What will be my g dash x? What formula I am using? X raised to n is n, x raised to n minus 1. This is equal to 5 x raised to 4. Okay. X raised to 5. So 5 minus 1 is 4. Okay. This function multiplied by this function, then this function multiplied by this function. Okay. So what will be my derivative? D by dx of 2 raised to x into x raised to 5 is first function into derivative of second function plus second function into derivative of first function. Okay. So what will be the answer? 2 raised to x into, so this is 1, 2, 3 and 4. Okay. So 2 raised to x into 5x4 plus x raised to 5 into 2 raised to x log 2 to the base e. Now what can I take common? Either you will find the answer like this, or you may find 2 raised to x is taken common. X raised to 4 also I can take common. What will remain? 2 raised to x is common. 5x raised to 4. So I have taken the x raised to 4 common. So this is 5 plus, from x raised to 5 I have taken x raised to 4 common. What will remain? X into 2 raised to x log 2 to the base e. Okay. Have you got this? Now you completely understood, Naveen? Excellent. Vipul got it. Aishwarya has got it clear. Dimple has done all the problems. Excellent. Aisha understood. Liza, Dimple, Mehak. Yes, Mehak, the questions will be MCQ. Okay. Yeah. Yes, Kevin. Very good. X log. Oh, I've taken 2 raised to x common. No? Okay. So 2 raised to x I have taken common. So this 2 raised to x and this 2 raised to x common. X raised to 4 common. So this is 2 raised to x raised to 4, 5 plus x log to the base, log 2 to the base e. Okay. Now x square upon e raised to x. So first we have done some single function Then we have done sums with addition of two functions. After that, we have done functions in which we are multiplying two functions, and now we are doing sums in which there is division of functions. Okay, so my hx will be of the form fx upon gx. Okay, when my function is of the form fx upon gx, what will this be? This will be, always remember that in this case, it will be second function whole square. How do I remember the formula? I am telling a tip, so please pay attention. In this case, it will be second function, and you start with second function. Okay, second function whole square in the denominator, and in the numerator you start with second function into derivative of first function plus minus first function into derivative of second function. Okay, so what happens if I have h to be equal to f upon g? Okay, then this will be what? The derivative of h will be equal to second function whole square into second function into derivative of first minus first function into derivative of second. Okay, it's as simple as that. So now let us do this. What is the first function? Like we did in the multiplication, similarly we have to do. Now my first function is x square. So f dash will be equal to what? X square derivative will be 2x. My second function is e raised to x, and derivative of the second function will be e raised to x. Okay, we know derivative. And see, here I have also written down the formula for you. So you can, while practicing also, while you go back to the YouTube, watch it again, you solve it on your own. If in any sum you get stuck, you can come back to the YouTube and you will be able to see, because I've also put in the formula which you are using. So here also, so this x square upon e raised to x. So this also I have told you that we are using quotient of function formula, that is when I have division of two functions. Okay, now I have this, now I have to put it in this form. So there this will be d by dx of x square upon e raised to x is equal to not a straight line. So this will be equal to, in the denominator, what is gx? Second function whole square, e raised to x whole square. I begin with the second function, e raised to x into derivative of the first function, that is 2x, minus first function is x square into derivative of the first function, second function, that is e raised to x. Now in the numerator, I take out e raised to x common. I can even take out x common. What will remain is 2. What will remain is 2 minus x upon e raised to x the whole square. So 1 e raised to x will get cancelled. So you can write this as 2x minus x square upon e raised to x, or you may even write it as x common 2 minus x upon e raised to x. Okay. Yes. So what happens here is, like, once you are able to do this, once you know the formula, it becomes easy. There are no difficulties for you to solve this. Is it now crystal clear? 2 raised to x minus x square upon e raised to x. Yes, Kevin, Dimple, Tanmeet, Ankur, Asif, Bharat, Shruti, Tamanna, Aditi. Yes. Okay. Now, similar to that, let us do another division of two functions. So let me put fx to be equal to e raised to x. Then f dash x will be equal to e raised to x. Now gx is how much? Dx is equal to log x. And what will be g dash x? Derivative of log x is nothing but 1 upon x. Okay, now I substitute. So I have d by dx of e raised to x upon log x to be equal to log x the whole square in the denominator, because gx the whole square, so second function whole square in the denominator. In the numerator, we start with the second function log x minus derivative of the first function. What was the first function? E raised to x. What is this derivative? E raised to x. Oh, why is that line come? Log x into e raised to x minus first function e raised to x into derivative of second function. What is the derivative of second function? 1 upon x into 1 upon x. Okay, so this will now be equal to 1 upon log x the whole square into, this is, and e raised to x also I take common, this is equal to log x minus 1 upon x. Now I cross multiply. What is the denominator here? Log x. The denominator is 1. Cross multiply and I find the LCM. I get this is equal to e raised to x. In the denominator, I take x common. So x into log x, the whole square. Now this will be x log x minus 1. Is that clear? Okay. Very good. Yes, it is totally clear now. Ankur, Nabeen, Vipul. Very nice, very nice. Kevin already is saying it's good. Now Asif has also understood. Ankur has also understood. Bharat, with Shruti. Liza, are you there, Liza? Yes. Now this is 2 raised to x into log x. Should I use multiplication? Should I use division? That only you have to be very careful about which formula are you using. Is it a multiplication of two functions, or is it a division of two functions, or is it simply one single function? That once you have understood, no, that is a stepping stone for being able to solve derivative and integration sums. Okay. Yes, Dimple, initially you were afraid of the chapter. Now it seems easy. Yes, it is easy. Yes, Mahima, good. Ritu, Nikita, Aditya. Yes, Baba Sahib. Okay, so now I have two functions and here it is multiplication. So my fx is equal to 2 raised to x and my f dash x is equal to derivative of 2 raised to x is a raised to x log a. So this is 2 raised to x log 2 to the base e. Okay. And what is my gx? Gx is equal to log x. And what is my g dash x? This is equal to 1 upon x. Now, my derivative of this function, my d by dx of 2 raised to x log x will be equal to first function into derivative of second function plus second function into derivative of first. So first function into derivative of second function, that is 1 upon x, Let me use a different color. So what is my first function? First function is 2 raised to x into derivative of second function, that is 1 upon x, plus second function is log x, into derivative of first function, this is equal to 2 raised to x log 2 to the base e. This is equal to 2 raised to x is common, so 2 raised to x 1 upon x plus log x into log 2. Okay, always remember there is a base e. Okay, suppose they may give in the option log 2 to the base 10 or log 2 to the base e. Then you have to tick mark log 2 to the base e. Is that clear? Yes, product rule. Aditya, Nikita, yes, Lisa, multiplication rule. 2 raised to x upon x, yes, plus log x, 2 raised to x log 2. Very good, very good. Wonderful, wonderful. I'm so happy. Yes. Somebody was talking about practical application. Many times, you feel that this, what do I need to, why do I need this chapter? But this is a practical example that we are taking, that when you want to find minima and maxima. So what is minima and maxima? Suppose I have a cost function, okay? So you know that as the number of units increases, what will happen to the cost? Cost is going to increase. Okay. But after a particular point, what happens is, because of marginal costing, is that your fixed costs have been covered, the cost decrease. Okay. So your cost may increase and then it may decrease. And you may want to find the minima like this. Okay. So this is also possible that you are wanting to find the minima. So what happens is that when you are finding marginal costing, when you are trying to find the marginal costing, this you want to see, you want to find this point. Okay. You want to find this point. At this point, your cost will be minimum. So you want to do that. Then you may even have profit. Okay. You may have profit where your profit keeps on increasing by the number of units you produce. But if you produce too many units, what happens? In economics, the price may fall. Then your profit may also decrease. Okay. Sometimes it is not possible to make that much of production. Then you may have to pay overtime. Then the cost of the product may rise. So in that case, what happens is your profit increases up to a particular level and then it decreases. So for such examples, what do? We use maxima and minima, and you will use derivatives to find the point at which the cost is minimum or the point at which the profit is maximum. So a relative minimum at a point x is equal to a will have the derivatives. So what happens is that once I start finding the derivative at the point at the minima, that is at this point. Can you see this point, red point? Here the f dash of a should be equal to 0 because this line will be, okay, I'll just, if I try to draw this line is parallel to the x-axis. So f dash a is 0 and f double dash a, that is if I find the derivative of the derivative. What do you mean by f double dash? It means I'm finding first I find one first derivative, and then if I find other derivative of this derivative, it is called as double differentiation. Then what will happen? My a value is increasing and my f double dash x will be like this. So this is greater than 0, then I will have a minima. So what is the condition for minima? A, it should be a continuous function. Okay. Second, my f dash of 0 should, f dash of A at this particular point should be equal to 0, and f double dash of A should be greater than 0. Okay. In that case, what the value of A I have obtained will be the minima value. Opposite of this applies to maxima. So at maxima, what happens is, I am at this point. At this point, what happens to my first derivative? It is constant. I mean, it is like this, parallel to the x-axis, so it is 0. But if I consider this at this point, at x is equal to some other number, I see that my f double dash of x at the point A is negative. Okay, because it is decreasing. Here what is happening? It was increasing, so it is positive. Here it is decreasing, so it is negative. Okay, so I hope you've understood the concept. When I want to know whether the given point, okay, at a given point, I have a maxima or a minima, what I do is I take the function, I find the first derivative, I equate it to 0. From there, I get a value of x. Then this derivative, first derivative, I find the derivative again of the derivative. So that is f double dash. Once I find f double dash, I substitute this value of x that I had got, and I try to find out whether that f double dash A is greater than or less than 0. If it is greater than 0, I have a minimum. If it is less than 0, I have a maximum. Less than 0 means I have a negative number, then I will have a maximum. Marginal cost. If now we will talk about marginal cost and average cost. Average cost, you know, whatever cost I have divided by the number of units, I get the average cost, isn't it? Whatever cost I have divided by number of units is average cost. But this is a very interesting concept called as marginal cost. If Cx is the total cost of producing X unit and the increase in cost in producing one more unit is called as the marginal cost. Suppose I am manufacturing 500 units. What if I want to manufacture 501 unit? So to manufacture that one more unit, what is the additional cost I will have to bear? Okay, and it is given by dc by dx. Whatever cost function I have, once I find the derivative, I get marginal cost. Okay, from this, when I equate that to 0, I get the value of x. Using this value of x, I substitute this value of x in the double derivative of the cost function or one more function of the marginal cost function. Then I get the whether I have a maxima or a minima. Okay, so this is marginal cost is represented by what? dc by dx. Okay, then I again find this d double dash of dx. Okay, and average cost will be equal to cx upon x. I'll write it down properly here. Okay, so this is one sum I want to take. From there you will come to know. So this sum is there in your textbook. The cost function of a company is given by Cx is equal to 100x minus 8x square plus x cube upon 3, where x denotes the output. That is, x is the number of units that you are able to produce. Find the level of output at which marginal cost is minimum, average cost is minimum. Okay. Now Cx is 100x minus 8x square plus x cube upon 3. I find the derivative of this, I will get the marginal cost. So what is my marginal cost? Will be equal to dc by dx. Okay. And as you can see, it's a simple equation. What will be derivative of 100x? It will be 100 because derivative of x is 1. What is the derivative of x square? What is the derivative of x square? 2x. So this 2x into 8 is 16. So this is and there is a minus sign, minus 16x. What is the derivative of x cube upon 3? What is the derivative of x cube? 3x square. So plus 1 upon 3 into 3x square. This 3 will get cancelled. So I am left with 100 minus 16x plus x square. Now what are the two conditions for minima? First is f dash of a should be equal to 0. This will give you what? This will give the value of x, a value of output. Okay. Using this, I can find the value of output, that is the number of units to be produced. Okay. And then I find out double dash of a. Okay. Whatever f dash a I have got, I will find the derivative of that. Then what I get is, if positive, there is a minima. Okay. Because you are at the end of the curve. From the end of the curve, you can go only up. You are at minima, you are here, and after that, you will be only able to go up. So, if it is negative, then it is a maxima. If it is positive, it is a minimum. Now, what is this? I have to find the first derivative of the marginal cost. What will be the first derivative? Derivative of 100 minus 16x plus 2x. What will be the first derivative of this marginal cost? It will be this. Derivative of 100 is 0. Derivative of minus 16x will be minus 16 because I already have this. This is x square, right? And derivative of x square will be plus 2x. Now, to find this, what should I do? I should equate it to 0. Okay. I should equate f dash to 0. Then this will be minus 16 plus 2x is equal to 0. Minus 16 plus 2x is equal to 0. So x is what? X is 16 upon 2, which is equal to 8. Okay. This minus 16 I take to the RHS. 2x is equal to 16. So x is equal to 8. Okay. From here, what I have got that at the, if I produce 8 units, my cost will be minimum. So I now find f double dash of 8. Only then I can say it's a minimum. Okay, it may be maxima also. So let me put f double dash of 8. For this, I need to find f double dash. What will be f double dash? Fx is how much? 16 minus plus 2x. What is the derivative of this? This is f. This is not f. That is derivative of minus 16 is how much? Derivative of minus 16 is 0. What is derivative of 2x? It is 2. So f double dash is equal to 2, which is greater than 0. which is greater than 0. So what are the conditions? First, I will put f dash a is equal to 0 and f double dash a should be greater than 0. Is my f double dash a greater than 0? Yes, it is. So what do I have? I have a minimum. Okay. I have a minimum. So at production of 8 units, my marginal costing will be lowest. Okay. Let us see the average cost. Okay. Let us see the average cost. I hope you've understood this. Yes, Pramod. Okay, Ankur, now you see the average cost. Here you will, same thing, same procedure is there. You will be able to follow here. Okay. Remember, when I have a minima, I have to equate f dash a to 0, and to find whether or not I have a minima, I have to find the double derivative. Once I find the double derivative, if it is positive, I have a minima. If it is negative, I have a maxima. Okay. Now, average cost is cost upon x. What is my cost function? This. So, my average cost will be equal to 1 upon x, 100x, minus 8x square plus 8 cube upon x cube upon 3. Now, if I take this inside the bracket, this is equal to 100 minus 8x square upon x is minus 8x plus x cube upon 3 will be plus x square upon 3. Okay, this is my average cost. Now, I find the derivative, average cost derivative. What will be the derivative of 100? 0. What will be the derivative of minus 8x? It will be minus 8. And what will this be? This will be 2x upon 3. 2x upon 3. Derivative of x square is 2x. Okay, see, it becomes so easy. You know, derivative of x is 1. Derivative of number is 0. Derivative of x square is 2x. Derivative of 3x square will be equal to 6x. You know, just you have to just practice. Okay. Now I have this a derivative. Now I put a c dash average cost equal to 0. That is minus 8 plus 2x upon 3 should be equal to 0. So solving this is 2x upon 3 is equal to 8. Okay, this minus 8 I take to this side. X will be equal to 8 into 3 upon 2, which is equal to 16. Okay, or equal to 12. This is 2 1s are 2 4s are. So 4 3s are 12. Okay. So average cost will be lowest when you are manufacturing 12 units. We have to check whether it is maximum or minimum. So what do? I find the double derivative. So double derivative of this will be what? Minus 8 will be 0. 2x by 3 will be equal to 2x plus 3. 2 upon 3. X will be 1. So, is it positive or negative? This is positive, which is greater than 0. So, I have a minimum. So, I have a minimum. And what will happen here? Because I have a minima, I will be equal, that will be equal to that x is equal to 12. Average cost will be minimum. Okay. Understood now? Yes, Liza, Aisha, Ankur. Now I hope you've understood. Take what cost is given to you, find the first derivative, okay, equate it to 0, you'll get the value of x, substitute it in the double derivative of the cost function or whatever function is given to you. If it is positive, you have a minima. If it is negative, you have a maxima. This is exercise 8a. So we'll just take the first sum and then we'll finish for the day. Okay, because tomorrow, next time also we have derivative and integration, so we'll be able to cover more sums. Okay, yes, there is a little bit of functions and relations remaining. So whenever I have time in the next 2 sessions, after we finish derivative and integration, I will be taking up that much. Okay. And if still we don't have time, then I will request for another lecture. But I think in the next chapter, in next 2-3 days, I will find the time and I will take you through I have already taken what is equivalence. I have already taken what is the functions of transitive, symmetric. So we have already done that. There is no problem with that, but I would like to take 1 or 2 more sums for it. Okay. Now the gradient of the curve, this is how much? Okay. So I have y to be equal to 2x3 minus 3x square minus 12x plus 8. Okay. Now gradient. Okay. What does gradient mean? I just have to find the first derivative. So y dash will be equal to 2 into derivative of 3x is how much? 3x square minus 3. Derivative of x square will be equal to 2x minus 12. Derivative of x will be equal to 1 plus derivative of 8 is equal to 0. Okay. So my gradient is equal to how much? 6x square minus 6x minus 12. Okay. Now, but they want you to find the gradient at x is equal to 0. So, y dash at x is equal to 0 is equal to 6 into 0 square minus 6 into 0 minus 12, which gives us the answer minus 12. Okay, so A will be the correct answer. The gradient of the curve y 2x cube minus 3x square minus 12x plus 8 at x is equal to 0 is minus 12. Okay, same thing in the second question. This will be equal to y dash 2x cube. What is the derivative? This is 6x square. Okay, 3 into 2 6 and x square minus 5x square will be equal to minus 10x and minus 3x will be equal to minus 3. Okay. Now this is my derivative, that is my slope. First derivative gives me the slope. I want to find it at x is equal to 0. What will be the slope of the line at x is equal to 0? That is, I want to find out the point at which the line cuts the y-axis. So at x is equal to 0, what do I have? 6 into 0 minus 10 into 0 minus 3 is equal to 0. Okay. So, what is the answer? Minus 6 into 0 is 0, minus 10 into 0 is 0, minus 3. So, B will be the correct answer. Okay. Now, this is a bigger sum, so we will take it next time. Okay, here what will we do is we will be using this where you have a function of a function and then we will use the chain rule and then try to solve it. Okay. So, I know this is a chapter that is very interesting. So many of you have started doing so well over here. Yes. Very good. See, excellent. So many answers I am getting the correct answers. Okay. So thank you all for your patient hearing. Have a great day ahead. Okay. Thank you. Vinuji?